So in this video, we're going to go over sum and difference of cubes. So this is a polynomial factoring method that's similar to difference of squares. So you've probably seen that one before. It's similar to that, but we're going to change it around a little bit. So let's start with sum of cubes. So in the name sum of cubes, it pretty much tells you what we have, but let's write it out. So essentially what we have here is we have a term that we could say a, or we could call a, that's to the third power, plus b, which is our second term, to the third power. And essentially here's what we can do. If we have two perfect cubes, we can take out this a and b, which is the base of our exponent, and we can say this is going to break down to give you a plus b. That's the first factor. The second factor is a squared minus a times b plus b squared. All right, now here's an acronym that I've seen to help you remember the signs, because when you're doing the signs of difference and sum of cubes, a good acronym for that is SOAP. So essentially, here's what this means. Same, which refers to this plus sign being the same as this plus sign. Then we say opposite, which refers to the second sign being opposite of this original sign. And then always positive, because this third, let's see if I can actually spell, always positive. Because this third sign is always positive. It doesn't matter if we're doing sum of cubes or difference of cubes. So now, hopefully you got this written down, because we're about to use it for an example. And we'll do a couple of these, but I'll try to make it quick and move on. So let's say we have x to the third plus 27. So now my job is to figure out, all right, I have adding, I have two terms. Now, obviously, x to the third, the base of that exponent is x. All right, so that's going to work like a. So that's x. But now I need to look at 27 and say, okay, could I rewrite this so that I have a number, so a number to the third power, and still end up with 27? And we could, because the cube root of 27 is actually 3. So we could say 3 to the third power is the same as 27. So my b from our original setup that we wrote down, 3 is the base of this exponent 3, which means my a is going to be x, and then b is going to be 3. So then when I factor this, once again, we can use SOAP to help us with the signs, and then we just have to memorize the setup. So the setup is a plus b, which is x plus 3. And once again, the sign is going to be the same, because in SOAP, s tells us it's the same sign, times x squared, or a squared, which is x, so x squared. Then we do the opposite sign, which is this o, so we make this minus, and then we're going to multiply a times b, which would be x times 3, which would be 3x, plus, because the last part of SOAP is AP, which means always positive, plus this b term, or b variable, which is 3 squared. So that would be 9. So we have just factored using, which that's a terrible box, we have just factored using sum of cubes. Let's do one more just so you can get an idea of this. So let's say we have, let's do one that's maybe a little bit harder. Let's do x to the third plus, let's say, 216. All right, so if we want to factor this, once again, first we have to recognize the setup. There's two terms, we're adding, then this is to the third power. So if we can write 216 in terms of a number to the third power, then that means we can use sum of cubes. So let's see if we can do that. So what to the third power would give me 216? Or you could also just do the cube root of 216. which will be 6. So in this case, A is going to be X and B is going to be 6. So then we write our factor, we're going to factor out our formula, which would be X plus 6, because remember, when we're doing SOAP, we write this out as a plus sign first because we keep the sign the same. Then we're going to multiply that by a squared, which in this case is x. So x squared minus, because we changed this sign to be the opposite. Now we do 6 times x, which is 6x. Then we're always positive at the end. And now we're going to take 6 and square it. So that would give me 36. So once again, we have just factored using sum of cubes. So now let's look at difference of cubes, which once again, I'm going to try to keep these examples a little bit shorter because this is just a basic video. It's not meant for every single example. All right, so difference of cubes. Once again, we can use this SOAP analogy or SOAP, not analogy, acronym to help us with this one. So the only difference between difference of cubes and sum of cubes is now we're going to have a setup that's a to the third minus b to the third, which factors a little bit differently because the sign for the first parentheses, our factor is going to be the same. So now it's a minus b. Then we start off the exact same way with a squared, but now we're going to change our sign to plus. Then we have a times b plus b squared. So the setup for this looks very similar, but it's a little bit different. And once again, SOAP can help you with this with the signs. So let's do a few problems like this. So now let's say we have x to the third minus. We can do a similar example. Well, let's just keep it simple. We'll say x to the third minus 1. So once again, we're looking for two terms, but now they're subtracted. So we know that's difference. We can see that x is the base of this third exponent 3. So a is going to be our x value. Now we just want to see if we could write 1 to a power of 3 to give me 1, and it would be 1. So b is equal to 1, which means I can factor this with difference of cubes. Once again, we can use SOAP to help us. We're going to say x minus 1, because we keep the sign the same, times x squared. Now we're going to change our sign to plus. Then we're going to take b times a, or a times b, which would just be x, because it would be 1x. And then this last part is always positive, and then we take 1 squared. So this would be our setup. All right, let's do another example. And hopefully you're pausing and trying these on your own, because honestly, this just takes a little bit of practice, and then you'll get better at it. So let's try 216. Let's try x to the third minus 125. All right, so now this one's going to present us with a few different problems, but let's just try this first. We have two terms, and actually I wrote this incorrectly. Let's do this. Let's get my color straight. X to the third minus 125. There we go. All right, so now basically what we want to do here is we want to look for two terms. Then we spot that this is x to the third. So you know part of your a value is going to be x, but we also now have a coefficient. So now I need to say, okay, could I write 216? Could I rewrite that as a number to the third power? And I could. It would be 6. So once again, a trick you can do to this is you can do the cube root of this, and that'll tell you the number that you need. All right, so now let's look at 125. We want to find our b value because we know this minus sign tells us difference. So now if we can rewrite b as a number to the third power, then we're good to go, and that tells us b, which once again, a trick is you can do the cube root of 125, and that'll tell you what the number is, which the number would be 5. So now we can use SOAP to help us with the signs, and then our setup's going to be a times or a minus b, because the sign's going to stay the same. So that would be 6x minus 5. That's our first factor. Now, this part can get a little tricky, but we have to do a squared, which in this case would be 6x all squared. So when you square 6x, the 6 and the x actually get squared. So just be sure that you pay attention to that part. So this would give me 36 Yeah, 36x squared. Now, in SOAP, the O means we're going to do the opposite sign. So if this was minus, we're going to change it to plus. Now we need to do A times B, which is 6x times 5, which is 30x. All right, and then the last term is always positive, but once again, we're doing 5 squared, so we just have to make sure we square 5, which would be 25. And then I believe we would be done. So there is our answer. So once again, the big deal or the big setup here is making sure that you know the setup for difference of cubes and sum of cubes, and then really it's just practicing some of these problems. And so, yeah, that's really the main idea here is to practice some of these problems, making sure you're paying attention to the signs and everything like that.